Welcome. Whether today you weren't in class for the 9-4 notes or maybe you're just having some trouble with some things and like to see things over a time or two, here's your chance to do it. You'll notice as we go through, there will be some problems circled. I'm not going to do all of the problems, but I'm going to do a little bit of everything just to make sure that we're rolling along okay. All right, let's start simple. First one, since we're just multiplying, really weak bonds, so if I see anything that's alike, I can cancel those out and get myself to a solution. That one goes pretty easy. They won't all be that easy, but hey. 3 and 5, that doesn't reduce anymore, but I do remember through my exponent rules that if I have the like base, I can subtract my exponents. 2 minus 1 is 1, and I put my solution where the larger exponent is. That's as far as I can go as far as number 2 goes. But now we start getting into the factoring part, which I've been warning you about. Here, whenever I see those plus or minus bonds like I do here, those are really strong. So the only way you can cancel those is if things are identical. So for instance, the x plus 4s are identical, those can cancel. The x plus 3s are identical, those can cancel. But then comes the moment of truth of whether you get this or not. When I get here, I cannot cancel the x's. That does not work. They are bonded to the minus 4 and the minus 3. Seeing the parentheses helps me know that. Unless these parentheses are identical, I am done. Same here. Now here, each one of these does have an x. I could cancel them out. But instead, I would look to factor the numerator, take the x out, which is what they have in common. Okay, and I'm leaving the denominator alone. But now, the x plus 5, that's a strong bond. I'm not touching that. But when I look at these, I'm like, ooh, weak bond. Okay, 2 minus 1 is 1. Larger exponent is down in the denominator. So it becomes x. Now again, don't do what I'm thinking you're thinking. Strong bond. Cannot cancel these. I'm done. Okay? So as we move our way up the sheet, ooh, more factoring. Okay? This is the x for some of you that have been doing it before. I need two numbers that multiply to negative 12 and add to negative 4. Let's see here. Negative 6 and positive 2. Multiply to negative 12, add to negative 4. If you need to draw out the x to do this, that's fine, but I'm just not going to on here. Hopefully then you also remember our shorties from before. These are both perfect squares. So again, I get my two quantities ready. What do I square to get x squared? X. What do I square to get 4? 2. And it's positive and negative with that. So now is anything alike? Yeah. The x plus 2's, leaving me with x minus 6 over x minus 2. And again, good to keep the parentheses because it reminds me the bond is strong and I can't cancel the x's. And I'm done. 6, same thing for some of you wondering, well, since all these have a 5 and all these have an x, could I take that out of each one? Absolutely. For the rest of us, though, I would take the one extra step and say, okay, these each have a 5. They each also have an x. I take the smaller exponent for my greatest common factor, and then I basically am doing the distributive property here. 5 times what gets me to 10? 2. X times x is x squared. Then I move to the next term. 5 times what is 15? 3. And I already have the x, so I don't need another one. When I distribute this out, I should get the denominator back. And if I do, I've done it well. So then again, don't touch the parentheses, the quantities. But I can whack the 5's. And 2 minus 1 is 1, so I'm left with 1x up in the numerator, and I'm set. And that's all we're going to keep doing through these. Here, again, another couple of diamond type problems. What do I multiply to get 24 that adds to negative 10? Well, I know they both have to be negative or both be positive to get a positive 24. So in this case, I know they're both negative. 6 times 4. And then again, multiplies to negative 12, adds to negative 4. I know one of each sign. I want the bigger number to be negative. And then again, what do we have that's in common? Those guys. Keep the parentheses to remind yourself, unless they're identical, I'm done with that. Okay, we're going to keep moving our way down the page here. When I get down to here, now again, personal preference. Some of you might start canceling right away. I don't suggest it. I like to look at one fraction when I'm doing these. So I'm going to multiply straight across. And I'm also going to do the same down in the denominator. Especially with all these fancy schmancy calculator buttons you have that make reducing so easy with everything, I'd go ahead and do it this way. Now I still have to try and reduce though with things. With my exponents, again, subtract the exponents, larger minus smaller. Your answer goes where the larger exponent is, the greater valued. 10 minus 8 is 2, larger valued exponent in the denominator, so that's where that goes. And then again, the 16 over 400, you can do math, enter. You can just kind of work your way through here. But 16 goes in once, goes in 25 times here. I don't really need the 1, but that's as far as I can go. Okay. If you keep flipping through your note packet, bring back down here. Now again, sometimes we're going to be doing individual factoring. Each one of these pieces is going to be its own little part. So for instance, I'm going to start just with that part. Okay? Take out what they have in common. Again, whatever's left over has to go in the parentheses. This looks like a diamond problem, but again, multiply to get -3, add to get 2. Let's see here, +3 and -1 gets me my -3 and my 2. Do all your factoring before you start canceling things. It's just going to make life easier on you. Okay, again, I need two numbers that multiply to -6 and add up to 1. +3 and -2 gets me -6. 3 minus 2 is 1. And now again, go looking for things that are alike. And we're going to get to a danger zone here momentarily. Are these two the same? Well, the one's positive, the one's negative. The x is negative, the x is positive. So not quite, but I can fix that. So let's look at this for a minute. We'll rewrite what we have left. What can I do to switch signs on this and make it just like this? Here's an idea. If I multiply this top quantity by a negative, and I change the signs on both of these, negative times negative is still +1, just like it was up here. Negative times positive is still negative, just like it was up here. So I've changed the way this looks, but I haven't changed the value, and that's a tool you can use if you ever run into this situation. So now these are both -1, these are both x, and now they can cancel, and I'm just left with that negative on the outside of my x minus 2, and I'm set. So these can take a little bit. You can run into some different type issues with these. For our next one, again, let's look at this like it's over 1. They're like, oh no, Harty, here come the cubes again. Yeah, you have to know your cube form. If you do, you are screwed on this. What do you cube to get each of these? Well, I cube 2x to get 8x cubed. I cube 1 to get 1. So again, I keep my two quantities along with my sign from the middle, and then again, remember the pattern. Square the first term, so square the 2x, which is 4x squared. Change the sign. Multiply my two quantities together. I don't want that negative in there, so 2x. And then my last term, 1 squared. Well, what a coincidence. Notice the numerator of my other term. Identical. Goodbye. X plus 3 over 2x minus 1. So I can cancel these x's, right? You better not be saying right. That one's done. Again, pluses or minuses are bonds. You have to leave them alone. And finally, one more time, still going to factor, still doing it piece by piece, so we're only looking at one part at a time. So I can take a 5x out of the numerator. I got the 5, but I need another x. 5 times 2 is 10. I already have my x. So again, if I distribute, I should get this back. Looks like another diamond or another simple one here. Multiply to get -6, add to get -1 would be -3 and 2. And if these are taking you time, you've got to make sure that you're giving yourself the time to do these. Practice makes perfect. It also makes you faster. Notice here, though, this divide means we're going to multiply by the reciprocal. In other words, we're going to flip the second fraction. So when I go to factor this, these two have actually been switched around. So the x squared minus 9 is what I'm factoring up above, which is -3 and +3. Because again, if I FOIL this out, my x terms will be gone. This is my new denominator. Take out the greatest common factor. Got the 15. I got x squared. I need x to the third. I get one more x. 15 times 3 gets me to 45, and I already have the x squared. Finally, now I can start canceling stuff. Identical quantities, or to some of you, identical parentheses. We'll wipe those first. See what we have left. You're like, ooh, multiplication. I can zap this all I want. 5 goes into 15 3 times. 2 minus 1 is 1. Bigger exponent in the denominator. But to hold my place, oops, let me come up. We lost that last part. Let me come up here, though. I have to have a placeholder up in the numerator. If all of your solution is left in the denominator, if you don't have this 1 here, we'd just deem it 3x. So that's all we have there. I'm hoping this really has worked out for you okay. Again, the assignment is down here at the bottom. If you have any issues, let me know tomorrow. Thanks.